have still a few things left, so let's move on rapidly here. We need to take this a step further. We need to go to be able to do some statistics related to the line itself, not separate on the slope and the intercept, but combine the two to say something about the line. That's the plots I showed you in the beginning. And here we jump right into it. Here is the confidence interval for the line. Look at this. If we look at the formula, this is, so I could take any point on the line. I could also take some x value, some height, for which I don't even have any data. So let's take 171.5 centimeters. I didn't have anyone saying they had this, height. And then I could estimate the expected weight for a person of this height, or maybe I should be more precise now in the way I say it. I could estimate the average weight for persons being 171.5 centimeters tall. That subpopulation, that is a number. There are a number of guys and girls out there being that exactly that height. We put them in their own little population group. All of you guys, 171.5 centimeters tall, you're there. Your average weight, your mean weight is given by the line, by plugging in the line, the slope and the intercept to get the line value, right? That's our expectation of you guys in that subpopulation. Your uncertainty comes like this. Or rather, here is the t quantile, and here is the uncertainty of that. Please note that it's a combination of something with n and something coming from x. It is more difficult to estimate something which is in the extreme of our data. The further away from the center we go, the more uncertain it becomes. This is the weight Vektstang. What would that be in English?
Lever.
What's that? Yeah, maybe lever. Yeah, leverage kind of thing. Yeah. But we're not done. Look at, it's almost the same. Almost the same. Now I'm going to use the line in a different way. I'm going to take, and this is how you might use it in a production side at a company. If you have a prediction line running by some kind of quality control, I go to you and I ask, what is your height? Your height is 176 centimeters. And I want to use my model to, that's where we use the word predict rather than estimate. Now I want to use the model to predict your individual personal weight, right? I'm going to use the line to do that. I don't care about all your friends in your subpopulation, because that would be the other thing, to estimate the mean of all of you guys of 176 centimeters. That's not what I'm doing now. Now I want to use the model, the line, to predict you as the individual. So I plug in your height, just as I did before. I calculate, of course, the point on the line. What else should I do? There is only one line, so it's the same value there. But the uncertainty becomes larger. Exactly one standard deviation larger. Namely, the standard deviation, which is the individual standard deviation of deviations from the line coming from one person to the other. So that comes on top of the estimation. This estimation here we can make as certain as we want. By increasing n, if we let n go up there, sample 100s, 100s, and 1000s, this uncertainty will go to 0. Because n increases, and the sum of x's, the sum of n, the sum of 1,000, the sum of a million x's, that will make this go to 0. So I could be as precise as I want on the uncertainty here, but this one, no matter how many millions or billions I spend on the experiment, the one will be there. So when I predict individuals, the individual biological variability is inherently part of the error and we cannot remove it by sampling. Otherwise, it's the same thing. That's the two. Here's an example. You can cut and paste to see how to actually put in the lines in your function, in your plots when using R. I'm not going to do the sort of R course here, but here is an example of a confidence interval, and here is similarly the prediction interval in the same case. What is done here is I take all possible x values and then I compute the confidence interval, and similarly for the prediction interval. The prediction interval is exactly one standard deviation larger than this one. And it's always like that the confidence interval is narrower than the prediction interval. It's more difficult to predict an individual than it is to estimate the population average. So that's how it is. And also note this thing about I have the best precision in the center and I have the worst precision out there, right? There's this, it's bending out there. It's not a dramatic effect, and the higher the n, the less, in a way, this effect is seen. Here we hardly see it actually. It's still there, but it's being dominated by the sigma here. That was now doing confidence and prediction intervals for the line. We're getting there. Question 8 out of 9. Yeah, that's of course false given what I just told you. But maybe some of you were a bit fast there on the buttons.